Hi mates, I'm Miguel Colomer and I'm going to present you our project for the hackathon, MLess at scale. First, some context about the team. We first joined in 2017 and from there we have been working together on different projects. I have a data engineer profile and Silvio and Chris are full stack developers with a clear interest in serverless technologies. What we do love about these technologies is that the development speed that they allow us to have by giving us tools to solve business problems without having to worry too much about the hardware, sort of being able to cook without caring about how the microwave all actually works. Indeed, we learned about this hackathon just 10 days ago, and we could manage to deploy a project thanks to the serverless way of doing things, and well, that's nice. Enough with context. Let's talk about MLess at scale. We all have heard the statement that nowadays 90% of the ML models never make it to production. And there are several reasons for this, but one of them is because sometimes it's not easy to actually deploy an ML model in production. MLOps can be overly complicated, and sometimes a data scientist that has developed a model might lack the knowledge or the time to deploy it. Our proposal aims to solve this problem by taking advantage of the serverless stack to do it. So, let's imagine we have a business that needs to predict future purchases of the visitors to their digital assets in real time to make smarter and more effective decisions. How we could do that? Maybe we could create and train a model with BigQuery ML, export it to Google Cloud Storage, and then enable real-time predictions with TensorFlow extended deployment over Cloud Run. It would be great, indeed, to have a button on the BigQuery UI that did all of that I just told you. But, well, we cannot put a button in the BigQuery UI, so we did the next best thing. We created a parameterized template with a YAML file where the user can declare the project where he wants to deploy the solution, the BigQuery ML model, the actual sentence of the model, the bucket name where he wants to store the PB file, and the name and location where he wants the Cloud Run instance to be deployed with the endpoint that will make the actual predictions real time. And all this can be done by running a command in a Cloud Shell or through a Next.js web app that we have already deployed. And now, well, demo time. Silvio will show you how actually we can do this with the web app. Thanks, mate. In the near future, we will add some extra features to the project. For example, before deploying the TFX container to Cloud Run, we could modify the container so that it could send both the request payload and the prediction results to the model to Cloud Login through Cloud Run. Then we could set up a BQ sync for the logs so we could monitor the model with a dashboard in Data Studio. Also, another benefit of this approach is that when retraining and redeploying the model, we could use the features of Cloud Run to have the different versions, and to in a moment we could fall back to a previous version if needed. Also, if the Cloud Run endpoint is invoked for a completely cold state, it would take a couple of seconds to the system to give the predictions. And depending on the latencies you need for your business case, you could set up the auto-scaling Cloud Run to a minimum of 1 to ensure the response in milliseconds on any case. And also, if you, instead of using BigQuery ML, you need to deploy a custom model in TensorFlow or Keras, you could use the same approach, just removing from the pipeline the create and train BigQuery ML model part and export your model to Google Cloud Storage in PV format, and that would work just fine. Well, if we could have that button in BigQuery UI to do all this, that would be great. And finally, the bonus fit. We work in the advertising industry, and to help us in our daily task, we have developed Prometeo, a workflow orchestration tool to help us automate data pipelines supporting all the data lifecycle phases, and with connections to many of our advertising partners in the market. The platform is fully serverless and is built over different GCP services such as Cloud Run, Cloud Build, Cloud Scheduler, Cloud Logging, BigQuery, and such. And we thought, what not add MLess at scale in Prometeo? So what we did is we developed a new pipeline template that allows us to schedule the retraining and redeployment of ML models with zero human intervention. That's, at the end of the day, is ML at scale. And that's nice. And finally, you can see here a little bit of how the UI of Prometeo looks like. Just so it has an interface where you can have different projects with different pipelines, you can run them, you can schedule them, and well, it works nicely. And that's all, folks. If you want to contact us to give us any feedback or questions or whatever, you can reach us if MLess GitHub repo, where you will also find all the documentation of the project. And thanks for your time.